Objects are in motion everywhere we look. The study of kinematics is the study of motion without considering its courses. For example, we can study the motion of a football without worrying about what forces cause or change its motion. In this chapter, we will focus on one-dimensional kinematics. In order to describe the motion of an object, we must first be able to describe its position, where it is at any particular time. This position should be relative to a convenient reference frame, which could be the Earth, or other things such as the airplane if we're considering passengers inside the plane. The change in position is known as displacement. We always use final position xf minus initial position x0. It's important to note that the displacement has both a magnitude and a direction. If we don't consider the direction, the size of displacement is called distance. It is important to distinguish distance here from the distance traveled we usually use in everyday life. When we say distance traveled, we mean the total length of the path traveled between two positions. For example, a person could go back and forth several times between two positions, and the total distance traveled could be huge. We have known that distance is defined as the magnitude of displacement, while displacement has both magnitude and direction. So that displacement is an example of a vector quantity, which is a quantity with both magnitude and direction. Distance is an example of a scalar quantity, which is a quantity that has a magnitude but no direction. In order to describe the direction of a vector quantity, we must designate a coordinate system within a reference frame. The direction of a vector in one-dimensional motion could be simply represented by a plus or minus sign. It could either be horizontally along the x-axis or vertically along the y-axis. People usually choose right and upward directions as the positive directions, but it is free to choose your own. The only thing is that once you choose the positive direction and start solving a problem, you cannot change it. One interesting thing to notice is that a scalar could also have a minus sign in front of the number, such as in the case of minus 20 degrees Celsius. This minus sign here has nothing to do with the direction. One of the other key concepts related to the motion of an object is the time. Time is an interesting term that all of us know what it is, but at the same time feel very difficult to give an exact definition. You might have heard of the legend saying that Einstein was asking himself what time is, and then he developed the theory of relativity. In the textbook it says, time is change, or the interval over which change occurs. It is impossible to know that time has passed unless something changes. I have found another definition online which might be a little easier to understand. Time is defined as the duration in which all things happen, or a precise instant that something happens. Here, something happens is also considered as a type of change. In other words, it is important to understand that if a system is unchanging, it is timeless. The amount of time or change is calibrated by comparison with the standard. The SI unit of time is second. Practically, we can just read the clock and get a time. For a particular motion, we are interested in the elapsed time delta t, which is the ending time minus the beginning time. For simplicity, if we make the beginning time t0 to be 0, then the elapsed time is simply the final time and noted as t.